Alrighty, ladies and gentlemen, welcome to the last part of chapter 1. We're going to look at 1.6 with density with our really cool lab demonstration today with our good friends Coke and Diet Coke. Alright, so let's kind of review what we went over our lab demonstration today, right? We had 2 sodas and I put it in a beaker of water, right? When I put Coke in, it was able to sink, right? While Diet Coke was able to stay afloat in the water, and we concluded that the reason why the normal Coke was able to sink was because it had sugar in it, right? 65 grams of sugar, that's quite a lot, making it more dense than the liquid water, therefore it's going to sink. While Diet Coke has no sugar, right? And is less dense than the density of water in that container, was able to float, alright? So we can see that density is related to an object's mass and volume, alright? So let's look at a more general definition of what density is. So density is a measure of how tightly packed, alright, how tightly packed the molecules of a substance are, right? How the more they're kind of pressed together, right, the more dense it is. Think about like how hard like a cement is compared to like a wood floor, right? It hurts more when you fall in cement because it's more dense. Imagine that each dot is a molecule. Label the following boxes in order from least dense to most dense. Okay, so let's look at this one right here. This one has the least amount of molecules, therefore make it the least dense because there's more space in between the molecules. So I'm going to call that 1 for least dense. Right? These are kind of like medium amounts of molecules, right? But there's still a lot of space in between. So I'm going to say that's like in the middle with a 2. And then look at how tightly packed these are, right? They're really tightly packed, therefore they're going to be really dense. I'm going to call that the most dense, alright? So we want to remember that every substance is made up of molecules, right? And how those molecules interact with each other kind of determines the characteristics of that substance. So let's look at this right here. Order the following in terms of increasing density, smallest to largest, okay? So we got Coke, Diet Coke, water, and salt water, and this is kind of like a summary of what we learned from our lab demonstration today. So we saw that Diet Coke was the least dense because it floated in water. So I'm going to say Diet Coke over here is less dense than water, right? So now let's look at what water was less dense to compared to what's left over, right? We got water down, we got Diet Coke down, right? And water was less dense than Coke, right? Because Coke was able to sink because it had a greater density than that water in the container, okay? But then at the end of the lab demonstration, we were able to make the normal Coke float in the water by adding what? We added salt to the water in that container, therefore making the liquid more dense than the object, the Coca-Cola, right? So that caused it to float, right? Making salt water the most dense from our lab demonstration. Okay, so fill it out in your Go Formative as a little practice. Go for it. Okay, now that you filled that first part of the Go Formative, let's look at and summarize what we observed from our lab demonstration. Okay, so when you have an object density that is greater than, this is the greater than sign, right, for math. When greater than liquid density, right, the object will sink, which makes sense, right? You have an object that is more tightly packed than the liquid surrounding it, it's going to sink to the bottom. Okay, so that was our Coke demonstration. But when the object density is less than that liquid density surrounding the object's going to float, which is our Diet Coke, right? So think about those little floaties on like pools, right? Those are a lot denser than the liquid of your pool, and therefore it's going to float up on top. So just try to really understand that conceptually as we are doing these density problems. Alright, so example numero uno. Cup number 1 contains water and cup number 2 contains rubbing alcohol. What happens when you put an ice cube into each cup? And now I want you to draw what happens, alright? I give you the values of density for water, which is 1 gram per milliliter, and the density of rubbing alcohol is 0.784 grams per milliliter. So the rubbing alcohol is less dense than the water, and I have the density of ice, which is 0.92 grams per milliliter, And what's going to happen? Okay, so as I can see here, the density of water is 1 gram and ice is 0.92. So the density of water is greater than the density of the ice. So if I have my liquid right here, right, and the ice is less than the liquid, it's going to be floating on top. Okay, it's not going to sink because water is greater. On the other hand, I have my density of alcohol, and let me use a different color to represent that. Okay, so density of the alcohol is 0.784, which is less than the density of ice, which is 0.92. All right, so if I have my rubbing alcohol over here, the density of the ice is much more tightly packed than the density of the rubbing alcohol. Therefore, the ice is going to sink to the bottom. Okay, it's going to sink to the bottom like that, which is pretty neat. Right? Each property is different. Okay, so now I want you to look at this. What can you tell us about the density of water, alcohol, and ice cubes? Right, from this little mind experiment, ice is less dense than water. Okay, and ice is more dense than rubbing alcohol. And then liquid water, as we see from these values, is more dense than rubbing alcohol. So if I put it in increasing order of density based on the values I see right here, the least dense is going to be the alcohol. Right, and then after that is going to be the ice, and then after that is going to be water. Okay. Pretty interesting that water as a solid, which is ice, is less dense than water as a liquid. Pretty cool, right? So I want you to fill out these kind of examples in your Go Formative, just as a reminder, and make sure you write these down as your notes.